Now, yesterday I shown this diagram in such a way, while understanding the fluid dynamics, you should also understand the way the water moves from greater heights to the lower heights to a greater extent. Here it's coming to one. No, you can also able to see that we don't know the depth of the water level actually. But these huge rocks, it is not the pebbles of that kind. But become and surfaces are very smooth surfaces, and the water is moving here and there, making a different structure. Okay, water is the only agent, water is the only fluid, okay, which can pass through anywhere in the universe, wherever it finds its own way, actually. Thanks to the nature in such a way, it is having a great attitude towards for the movement of this kind of a fluid from high potential energy to the lower potential energy and makes it on its own way fluid. If you assume that a planet without water, the life on that planet may be a miserable task. Of course, you can expect another kind of fluids also at a different temperature. Water is the only agent which can expect all the three phases, either maybe in the form of a liquid, or maybe in the form of a gas, or maybe in the form of a solid ice. Okay. To know this up to this extent, let us see that how it has to be having for the next slide. My God, the structure or maybe theory will not be restricted only for the water bodies on Earth. We can extend this theory even to the extent of the sun. The top left corner, you can see that actually sun is very active and having an energy which is emitted at quite high speed. The lava means or maybe CMEs they can call coronal mass ejections which are emitted by the sun moves at about 700 meters per second and reaches even to the extent of the Pluto. Extent in the sense, the third planet is the third planet from the Sun, the Mercury and the Venus, okay, about a distance of about 150 million kilometers on average, but the Sun emits radiation. Those emitted radiation will travel beyond the heliosphere, beyond the sun sphere, they can call actually sun sphere. If it is happening such certain things, it possesses highly energetic particles like electrons, proton, helium nuclei, iron, some lighter elements we can call. It also possesses the electromagnetic radiation different wavelength, different spectrum of the time, preferably the visible, ultraviolet, and other things. Thanks to the atmosphere and the atmosphere process from the ultraviolet radiations by interactions, and it allows only the visible radiation to reach the surface of the Earth and making the Earth as the beautiful planet for the life to exist on this planet, in this universe. Of course, we can restrict this study to the solar system to a great extent. On the right, you can see that right side of the picture on the top. This is the close picture of it is not from the camera. It is from the data which is obtained from the different satellites which were observing the sun constantly. The sun emits radiation. These encyclopedia things, whatever you are expecting, is appearing in such a way that coronal mass ejections. These loops are known as the faculae. The dark regions are known as the sunspots. Sunspots are nothing but the dark regions which are appearing on the sun, on the surface of the sun, maybe extending till to the deeper extent, where the temperature of those regions are less, relatively less compared to the surrounding areas. That's why the sun's temperature is not constant actually. The atmosphere of the sun is about 6,000 degree Kelvin. Those regions are having a temperature of about 4,000 to about 4,500 degree Kelvin. Even if you take it either in terms of the degree Celsius or degree Kelvin, about 273 is not a big issue, maybe a few orders of magnitude, but still the temperature on the different planets and the solar system and the stars are measured in system of international units, SI units, in terms of the degree Kelvin. This is how it has to happen. See the things on the left bottom corner, sun is having some periodicity, solar cycle they can call, solar minima to the maxima. Sun is active when this maximum, it is in its maximum peak, like almost sinusoidal wave. And the periodicity will do over. But if you expect, it is a cycle of 11 years. If you write sinusoidal wave, about 360 degree closer loop actually, it takes 22 to 23 years, 22 they can call, or a half cycle of about 11 years. Means minima to maxima or maxima to the minima to cover half of the cycle. To extremes they can call 11 year cycle. 2019 to 20 was in its minimum. Now we are going for the maximum. Think if sun is very active, sun puts a relation of this kind. This generates a sphere. This sphere is known as the heliosphere. Heliosphere gets the coming radiations from outside the sun's sphere, not from the sun. I am saying that the heliosphere beyond Pluto and protects the Earth and other planets also in receiving the high energetic particles. High particle of that kind. Fine. If this is the case, if when sun solar studies, so when sun is in minima or quite significant call, we will receive more galactic cosmic rays from the galaxies. Okay, not from the cosmic rays from the sun alone. But actually, you can see right bottom, 2001 to about the thing, how during solar cycle, the sunspot number will vary. Sunspots are nothing but the dark regions on the sun, okay, where the number will change. If sun is active, number of sunspots are quite larger. If sun is really relatively absent, we can't call it as the weak sun of that kind, then the it means that the number will come down. Sorry, number will come down. This is a periodicity. Why I'm saying that this is also a fluid dynamics. Okay, even if you call it as a plus point of the time, it is also called as a fluid mechanics. One can work it out on fluid mechanics on a similar strategy, similar analysis. The way we worked out with the glass of a cup of glass of water into the extent of the sun or maybe other stars of the same kind. Let us see here. Then, where you find fluids in fluid mechanics? Where you find academics? Fluid mechanics is the physics of flowing of matter. Matter is not for solid, it is flowing of the matter, whichever the way that may be includes. We are not limited to the extent what we are giving an examples here. Cars moving through the traffic, mainly because of the increase in the fluid, waste flowing through the severe systems, and the gases moving through an engine, like hydrodynamics or aerodynamics, or sap moving sucrose from the leaves to the distant parts of a tree. These are fluid mechanics. Even other examples of the fluid mechanics that may include the existence of the buoyancy force. Why you will float in a dead sea? I don't know if you have heard it or not. A dead sea is the sea you pond. We see you can float. We will float actually on the Dead Sea. How the surface tension acts. The surface tension allows the objects to remain on the surface. Healing, for example, for any kind of a cut of a skin, blood will ooze out, coming out of the skin, but that will wound in no time, depending upon the amount of the hemoglobin and the iron content in a blood cells. That will wound. That makes the dynamics, fluid mechanics actually. Then vacuum formations involve liquids. If you allow the water to boil, you maybe just watch. Maybe tomorrow, whenever you are having a time to be there in the kitchen for some time, either maybe in hostel or maybe in your house, whenever the water boils, you're having a different structure on the surface. Just watch it actually. For curiosity, you can have something a colored water also. Doesn't matter. Before you want to have a cup of tea, try to see that how that water boils. Then you pour the tea powder along with the milk and sugar. Just think. Motion of an ants also, or even flocks of birds moving in unison kind of a fluid. These are all some of the examples actually to make you comfortable with it. Why we study in physics is nothing but physics rules, physical laws are governing them. If you go still further as an insight, fluids have a bad reputation. Why? Because their detailed behaviors or characteristic properties are governed by Navier-Stokes equations. If once you bring the mathematics into the physics, people will run away, which pose a great mathematical difficulties. I'm not saying that it is impossible. We were bearing those academic syllabus in the academics, and there are no choice for you also. You have to listen to me till the end of the semester, whether you would like to it or whether you would like to, whether would you like it or not, that's a different issue. Stay happy. It is often unnecessary to solve these equations to obtain a great insights into the behavior of the fluids, because not required actually, but some of them we can make approximations we can do that. One can often make the progress with the right set of approximations, there is no doubt. To start, let's say that we will analyze the mechanics of a very simple problem, maybe a problem that is similar to the floating of a fluid or a liquid on some surfaces. Fine. I hope, are you able to see the screen and able to hear my voice? At least one response.
Yes, sir.
On the right, you can see there some photography, the same thing. When the ship is moving at the bottom place here, the water is falling. Here, the car is moving. That's different. Okay. Mechanics is the oldest physical science that deals with the stationary moving bodies. Stationary bodies also that also deals with the moving bodies under the influence of the some forces. A body is moving. This is even the water is stationary. If water is stationary, it will move. Even under moving bodies also it can move to a great extent. But the same branch of the mechanics that deals with the bodies are called statics, while the branch that deals with the bodies in motion are called dynamics. Dynamics means the same place. Fluid mechanics, which can deal with the fluids at rest, is known as fluid statistics. A fluid in motion is known as the fluid dynamics. It's don't get confusion. And their interactions of fluids with either solids or other fluids at the boundaries are periphery. This is a boundary. This is a boundary. When they are getting a boundary, some interactions will happen actually. Fluid mechanics is also referred as the fluid dynamics. There is no doubt by considering the fluids at rest as a special case of motion with zero velocity. If you say that the velocity is zero, then the fluid is said to be at rest. Then we have water in a cup, maybe water in a bottle, maybe water in a pond. There is no doubt. Maybe a lake they can call. But not be water in a river, want to be water in a lake, water in a canal, water in an ocean, of that kind actually. The bottom side, you can see that here a car is moving, no doubt. This is the air. Maybe the picture of it, you can be able to see that texture. To make that answer means that the air has to have a great control. The structure of the vehicles. Okay, even though the four-wheeler others also has to follow the fluid dynamics. Aerodynamics, you need to break alone. See that if you are getting a water time, it opposes, it opposes and it resists for the moment of the moment motion of an vehicle at a slowly rises. When it is down there, it's not that it can come and come up to this section and can go. No, the rate window planes will break once it happens like that as a strike actually. That we will see later. May not be going to that example of that kind. Means fluid mechanics deals with the behavior of fluids in general, that is either liquid or gases at rest and also in motion. It means to say that basically a study of the physical behavior of fluids and fluid systems or the laws which are
Sir, voice ಕೇಳಿಸ್ತಿಲ್ಲ sir.
hello or
Sir, voice cut ಆಗ್ತಿದೆ sir ನಿಮ್ದು.
okay. The physical now behavior of fluids and fluid systems.
Hello sir.
Yes. You are unable to hear?
Yes, sir.
Are you able to hear me right now? Hello?
Yes, sir.
ಇವಾಗ ಕೇಳಿಸ್ತಿದೆ sir.
Okay, no issue. I will continue. Sorry. Okay, for interruption. Maybe some kind of a signal error may be there at that moment actually. Are you able to see the screen also?
Yes, sir.
Yeah, means basically this is a study that can govern some of the laws are governing the behavior of movement of the fluids, either maybe at rest. Of course, if they are at rest, we can't call it as their movement actually, or maybe in the motion or including the system of that kind. Some action of forces on fluid and of the resulting flow pattern also will disturb. Means Fluid mechanics itself is also divided into several categories that we'll see later, no issue. The motion of these fluids can be approximated as either compressible or incompressible liquids. It is very difficult to compress the fluids to a great extent, as liquids, especially water, or you can't, or even some of the gases at low speeds, you can't compress it, which is referred to as the hydrodynamics. If a subcategory of the hydrodynamics is known as the hydrologs, which deals with the liquid flows in pipe and in open channels. Open channel means a channel where it can takes away the water from one place to another. All rivers are having the channels, either left channel or right channel of that kind, left bank or right bank we can call. Water will be released. Now it's the monsoon season. If the reservoir gets filled up to a great extent, water will be released from the dams or check dams or reservoirs they can call. They can't hold the water to a great extent. This dynamics one has to understand. Of course, while construction of all dams, construction of the channels, construction of the canals, construction of the reservoirs, construction of the pipelines which can take water from one place to another place, either for Kaveri or Kabini or the whichever river you can call, or the particular parties what they are trying to have the water from one place to another place is also the same case. They might not have understood physics, but at least they know that. Means to say, this gas dynamics, what we are expecting, deals with the flow of the fluids that undergo significant change in the density. If the density changes, certainly an active mass of solid becomes liquid, and then liquid becomes gas, or maybe reverse also. There is a possibility that a solid may directly be converted into the gas, like an camphor to the gas, or solid ice may be converted into the vapor, water vapor. The flow of these gases through some nozzles at high speeds makes this gas dynamics. See, the flow of these gases through the nozzles, for example, water vapor, if you are allowing, or say any kind of vapor, if you are allowing through the nozzles, it uses the huge amount of the energy. Means to say, the category of aerodynamics deals with the flow of the gases, particularly air if you take, over bodies, such as an aircraft. Last picture also I shown that for the car. Maybe the rocket has to go through the atmosphere. Aircrafts will be within the atmosphere, and automobiles at high speed or even sometimes low speeds have to undergo all kind of an aerodynamics. You can't take the deviation wherever you want. Some other specialized categories like meteorology, you are getting the rain, you are getting the winter, you are getting the summer, morning may be in hazy, morning may be in cloudy, afternoon may be in clear sky, morning you may be getting a fog, evening you may be getting a wind. These are all these things within the meteorology is the flow of the fluids, particularly the water and its vapor in the atmosphere. Oceanography, oceanic water is not stagnant. Entire oceans are moving from one point to the another point, like Pacific Ocean, Indian Ocean, some Red Sea, Arabian Sea. They are making the convection and the transport of the energy from high energy to the lower energy, either in terms of the temperature or from higher gravitational potential to the lower gravitational potential, makes it as the dynamics. For hydrology and all these three branches deals with the naturally occurring flow of fluids, preferably water be against. Let us come to the syllabus. Of course, this is also a part of the same case. How it has to happen? How one can define the fluid right now? Fluid is defined as, at the bottom I mentioned, one which under continuously applied tangential stress starts deforming continuously as long as shear stress is applied. My God, the physics has come into the picture. No way here. Means, assume this is a cylindrical tube pipe. If you apply a force from the top, stress should be down. That is, normal stress is downward. It opposes the force is upward. Okay. Instead of that, if you apply tangentially at the top, this is the from the left to right. I am showing it as an example in blue color arrow. Is for the shear stress. The opposition also from all the bodies within the should oppose. In fact, what happens here, you can see on the right top corner, if all forces are acting on the cube from all the direction, confining stress they can call stress equals from all directions, the object is said to be stationary at that point. There are possibilities, you can pull it on either side. These two sides are zero, there is no force applied on that. If you pull it on those sides, tensional stress they can call, where you are pulling horizontally. See, or you can compress it also. Compression stress, both are stress. Okay, strain is the one, the force you are applying. Stress is the one, either you can go for elongation or maybe the compressional stress. Here, shear will happen in such a way. Why here is called, it is defined in such a way, applied a tangential stress. Tangential stress starts deforming continuously as long as the shear stress is applied. Shear stress means a bottom panel is moved towards left, top panel is moved towards right, or maybe reverse also. Bottom is moved towards right, top is moved. You press your hands in an opposite direction, keeping the palm, that is shear stress. If you are allowing them only in one single side, you may not get the friction at all. That's why here it is shown in such a way that the top is moving, bottom is fixed, bottom layer is bone layer is the fixed, top is moving. This is the vertical line of the fluid. If it is moving, the top of the surface layer of the water moves to a great extent. As you come down, the gradient is the rate of change of speed of the fluid with reference to the y is decreasing. This is the shear stress. Means to say the object or fluid moves with a velocity known as the u. As you go down, the delta u by delta y will come down. See, this is so much. Here, see that this is so much actually in the sense. Okay, even the slope remains constant here actually, it moves with the same speed, but u will change. Delta u by delta y will change, but u remains constant actually. Okay, means in other words, it can flow continuously as a result of shearing action. This includes for either liquid or for gases. Means what do you think of a fluid actually? This is the contacted area. Okay, if you are deforming here, green color arrow, you can see that shear stress tau is referred by force acting per unit area. With some force, upper plate is moving along. This is the fluid actually deformed by shear strain with an angle of an alpha. Okay, deformed rubber you can call it. It is a material. If not, fluid also can happen. Fluid will not have the same case. Instead of the angle of that content, I think can move. A substance in liquid or gas phase can move, is known as the fluid. A solid can resist the applied shear stress by deformation, but a fluid deforms continuously under the influence of a shear stress, no matter how small. That's why in solids, stress is proportional to the strain. Okay, but in fluids, stress is proportional to the rate of change of the strain rate, they can call. Instead of rate, when a constant shear force is applied, a solid eventually stops. It can apply a brake for deforming at some fixed straight angle, whereas fluid never stops deforming and approaches a constant rate of strain. Means to say, deformation of this rubber block placed between the two parallel plates shown in blue color plates under the influence of a shear force from the top. Means the shear stress shown is that on the rubber, which is an equal and opposite shear stress acts on the upper plate actually. That is for the example actually. Being this, the normal stress and the shear stress at the surfaces of the fluid element here it is shown. This is the normal stress. This is the tangential. A force acting on this is in dA. If you have to apply normal stress is F by dA. Shear stress is tau F by d of that kind. This is it. Means for stress can be represented by force per unit area, and some definitions I have mentioned here. When the walls are removed or liquid container is tilted, a shear develops as the liquid moves to re-establish a horizontal free surface. Being this, see that this is a free surface, liquid is there. If there is no surface, it acts like a boundary. Molecules of a gases will move randomly. This is the dynamics which is happening in the gas. The same dynamics may also happen in liquid, provided they possess some energy. This is only example. You can go through it, no issue at all. This is an intermolecular bonds, or which are stronger in solids and weaker in gases. See that this is the strongest in the bonds in solids. Maybe the liquids still weaker in gases. They can move randomly. The tendency of continuous deformation of a fluid is called the fluidity. That is why if the people change their mind from time to time without having a constant thought, instead of fluidity, they will call it as the stupidity. But we should not behave like a stupid people of that kind. The act of continuous deformation is called the flow. Flow means that a constituent of the fluid particles continuously change their position related to one another. Means it is changing from point to the point here, that you can refer wherever you wish actually. That is referred. Yeah, here some applications are that area fluid mechanics. See, artificially hearts are artificial hearts are prepared actually. Fluid dynamics is used extensively in the design of an artificial hearts. Shown here is the Penn State electric total artificial heart. Is water is flowing naturally. Same thing. Power plants works on the dynamics. Industrial applications where fluid like an hot engine moving from the turbine to the rest of the part, hot and cool junctions they can make. Wind turbines, piping and plumbing systems also works on fluid dynamics. Aerodynamics, human body temperature works. Blood in a vessel moves because of the fluid dynamics. Aircraft and spacecrafts because of both within the aircraft and outside also should be worked out. High-speed cars will move, high-speed ships will move because of the fluid dynamics. Maybe a paste, acrylic paste which is coming out of a dump fluid. This is the same thing. Maybe even a extinguisher of the fire, water coming out of a pipe, any turbines, even puffs, that is because of the aerodynamics. A rocket, sorry, an aircraft, high-speed trains, the submarines, nuclear wars, high ships are working on the concept of fluid mechanics. See that the water is flowing. Okay, this is mainly because of that. We should understand this in a better way. Even physiology and medicine also say that blood pumps can be pumped. Ventricular and assisted devices they can cause. Some examples I'm saying that you just remember some of them. It not be always. Water sports, maybe cycling, offshoring of this racing, surfing over the water body, even the cricket where you like it more to a great extent, swinging of the ball towards left or right, where batsmen may not find it the path, the way the bowler has made a bowling depends on the dynamics, fluid dynamics. Even the racing cars, auto racings. How do we study fluid mechanics? By following basic laws of physics, like either conservation of mass, conservation of momentum, Newton's second law of motion, conservation of energy, second law of thermodynamics, plus equation of state, constraints of laws which can govern those things. Because we are bringing the mechanics and physics to a greater extent. This leaves with, of course, from this slide, I will repeat tomorrow, means on Monday at now. Goes with the ideal gas equation. How do we study fluid mechanics? Rho is equal to P times M by RT, and Newton's law of viscosity will also come into the picture, where the dynamic of viscosity will be involved. One can define the viscosity. It is defined as the resistance for the fluid, which is being deformed by the application of shear stress. In everyday terms of viscosity is nothing but thickness of the fluid. Thus, water is thin, having a lower viscosity, while honey is thick, mainly because having higher viscosity. Common fluids, for example, water, air, mercury, obey Newton's laws are known as the Newtonian fluids. If they don't obey, other class of fluids, for example, paint, polymer solutions, blood, do not obey the typical linear relationship of the stress and strain. They are known as the non-Newtonian fluids. Unit of viscosity gives us that Newton second per meter square or Pascal second. Some geological fluids of mechanics also be there. See, that's sucking of water. This is on Jupiter. This is at the Earth convection due to the volcanic eruptions. Some cyclones which are happening, tornadoes of that kind. Phases of fluid mechanics. I want your photograph in the third row, third column, third row actually. Archimedes, Newton, Leibniz, Bernoulli, Euler, Navier-Stokes, you can call together. Reynolds, and Tyler. They're all the people who have worked out from almost 287 BC till to the extent of 1975. Any queries and questions? I'm very happy to answer you. There is a time to wind up my class. I will shut off this at this point because it may end soon actually. Hardly. Any queries? There are no. Thank you for attending class. I will share the link. I'll stop this recording. If you wish for recording talks, so okay, I will share that recording talk. It is already there in YouTube. If you search on my name, it will come. I will put it as a second class for you. The same thing will be continuing actually. Thank you. Thank you one and all. Have a nice time. See you for Monday's class by 8 p.m.